So now let's go over how to graph polar functions in polar coordinates. So there are a couple different ways to graph them. Some people can just look at a function and graph it right away, and others not so much. I'm going to show you a method that might take a while to get, but it's sure to work and it's fairly easy once you get it. So let's go ahead and look at this first function, r equals 1 plus 2 sine theta, and we're trying to graph it here on this polar coordinate. So the method that I'm going to teach you guys how to use is to first graph it on Cartesian, Cartesian being x by y, so this is the x-axis, y-axis, this is the x-axis, and then kind of looking at and transferring it onto this polar coordinates. So I'm going to graph, instead of r equals 1 plus 2 sine theta, y equals 1 plus 2 sine x. So I went ahead and did that, and I marked some points out. I went ahead and wrote the intercept, the x-intercepts. And now let's look at how we can transfer this information onto the polar coordinates. So the method that I'm going to teach you guys, pretty much what you're going to do is you're going to look at the Cartesian graph, the y versus x, and you're going to look for these inflection points, maximums, minimums, intercepts, x-intercepts, and any values on the x-axis, such as pi over 2, pi, 3 pi over 2, and 2 pi over 2, that correspond with the polar axes. And we're pretty much going to split this graph into different parts and copy it onto here. So let's see what this means. So let's start at x equals 0 here. So at x equals 0, we have a value of 1, okay? So what we're going to do is we're going to plot that on the polar coordinates. So instead of x, we're now talking about theta. So remember that in a polar coordinates, we have 360 degrees, or 2 pi radians, and we're going to be graphing in radians. So 0 corresponds with this axis right here. So at 0, we have a value of 1, which in this case it's y, but we're going to look at it as r in the polar. So r equals 1 when theta equals 0. So this is the angle theta equals 0, and we're just going to put a dot right here at where our r is going to be. Now we're going to look to our next important point on the Cartesian graph, and it's going to be this pi over 2, comma 3. So pi over 2 is an important point because it's this axis right here. It's a pretty easy one to graph, because remember this is 0, pi over 2, pi, 3 pi over 2, and then coming back to 2 pi. So at, pi over 2, we have a value of r equals 3. Once again, this is y, but we're transferring it onto the polar, so it turns into r equals 3. So let's go ahead and graph that. We're looking at this angle right here, and we're just going to go and plot that. So now that we have the 2 points in our section, we're just going to look at what this graph is doing. So in this case, it's just increasing from 1 to 3, and never goes above 3. So we're just going to kind of copy that onto here. So we never want to exceed 3. 3 is going to be right here, and we're just going to want to increase up until we get to this point. So that's how our first section is going to look. Now let's look at this next section, which is from pi over 2 to pi, because once again pi is a pretty important angle, because it's right there. It's one of the axes. So at pi, let's go ahead and plot that. We have r equals 1. So if this is pi and we're going out positive 1, that would bring us out here. Ignore these negative signs. I know why they're here. Whoever made this coordinate system, they also put a y and an x. That shouldn't be there, and these shouldn't be negative. These are all positive, because we're going up positive r's. So we're going up positive 1, and if we look at this, we're going to have all positive values, because it's all above the x-axis, and it's just going to be decreasing. So the distance out from the pole, the radius, they're going to start big, start at 3, and then they're just going to get smaller and smaller and smaller up until they reach this 1. So it's just going to look like that. So now let's look at this next part, which is from pi to this point right here, which is 7 pi over 6 comma 0. So this is an important point because it has an r value of 0. It brings us back to the pole. So I'm just going to go ahead and put a point at the pole, and we know that it's going to have to approach this point from an angle of pi, which is over here, to an angle of 7 pi over 6. So an angle of 7 pi over 6, well, that would be kind of like this, that angle out here. So all the values are still going to be positive, so it's still going to be out here, and we're just kind of sweeping from pi to 7 pi over 6, and it's going to be approaching this r equals 0, so it's going to kind of look like that. And here's where it gets a bit tricky once we get these negative values. So we're starting from 7 pi over 6 comma 0, and we're going to 3 pi over 2 comma negative 1. 3 pi over 2 is over here. 3 pi over 2 comma negative 1, so that's an r value of negative 1 with an angle of 3 pi over 2. Well, 3 pi over 2 comma 1, that would be this point right here, but we're doing negative 1, so we're going to kind of go to the other side of the coordinates, which would bring us over here. So it's kind of like pi over 2 comma 1, and those are the same points. Pi over 2 comma 1 and 3 pi over 2 comma negative 1, they're the same points. So let's look at how this graph is changing. Well, all the values from 7 pi over 6 to 3 pi over 2, they're all going to be negative, and they're getting more and more negative. So we're sweeping from 7 pi over 6 to 3 pi over 2, so that's going like that, but all the values are going to be negative. So we're going to the other side of the coordinate system, so we're going to kind of be sweeping from here to there. And we're starting at the 0, and we're coming up to this point, to this 1, so it's going to look like that. Now let's go up to this 0 value again, and remember, 0 values are important values to graph. They tell you a lot about the polar, and I went ahead and solved for the 0. If you guys don't know how to do that, just plug in y equals 0 and solve for x. You get 11 pi over 6. So from 3 pi over 2, which is here, to 11 pi over 6, which is kind of going to be somewhere over there. And let's look at how this graph is changing. Well, it's negative the whole time. So instead of looking at this, we're probably going to be looking from here, coming out here, because that's the opposite of this. And it's approaching back to this 0. So we're going to be coming from here and going back to that 0. So that's this little loop is what really confuses lots of people, because our angles, they're out here, because this loop is corresponding to these angles that sweep from out here. It's just that since the Cartesian graph is negative that whole time, we're kind of going to the other side of we're kind of mirroring it across this line on the polar. So now let's finish this up from 11 pi over 6 to 2 pi, which is back here. It's going to be all positive, and it's going to be approaching 1. 1's already a point on this graph. And we're looking at these angles right here. It's all going to be positive, so all these points starting from 1, it's just going to be out here. So that's a graph of r equals 1 plus 2 sine theta. And next couple of videos are going to be a bit quicker, so you can always refer back to this video if you don't get something. But that's the basic method. We're really looking for these important points on the graph. Usually you're starting at 0 to 2 pi, but as you'll see sometimes it'll be from 0 to pi. We'll have different periods. But basically we're looking for inflection points, maximums, minimums, intercepts, and any angles like pi over 2 or pi that correspond with the axes on the polar.